Time is a fascinating concept that has fascinated scientists and philosophers for centuries. We use it to measure our lives, mark important events, and plan for the future. But what if there's more to time than just what we experience in our everyday lives? What if there are more dimensions of time that we have yet to discover? Is it simply a one-dimensional line that moves inexorably forward? Or is there more to it than meets the eye? This is where the concept of multidimensional time comes in. What if time is not just a linear progression from past to present to future, but a complex and multi-layered entity that exists in more dimensions than we can perceive? In recent years, some of the most brilliant minds in physics and mathematics have explored the possibility of 2D time, opening up a whole new world of possibilities for our understanding of the universe and the nature of time itself. Step into the unknown, where the mysteries of time unfold. I am the timekeeper, and this is 2D time. Over the years, several scientists have explored the possibility of 2D time. Some of these included Zach Bars, Neil Turok, and Faye Dowker. So what is 2D time? Well, imagine time as a two-dimensional plane, much like a graph. In this plane, one axis represents what we typically think of as time, while the other axis represents a new dimension of time. It may seem strange at first, but the concept of 2D time has profound implications for our understanding of the universe. It's like adding an extra dimension to our understanding of time. One of the coolest things about 2D time is that it allows for the possibility that events in the past and future can be connected. Imagine being able to reach back in time and prevent a tragedy from happening, or see what the future has in store. In fact, the motion of particles can be affected by the time dimension in 2D time. It's like being able to move in a new direction that we never knew existed before. This formula T equals T prime plus I multiplied by T double prime, where T is the 2D time, T prime is the regular time, and T double prime is the extra dimension of space-time, may look like a secret code that only physicists can crack. But it's actually the mathematical representation of time in 2D space-time. It's like a roadmap that shows us how to navigate through time in a whole new way. Who knows what secrets we'll uncover as we continue to explore the mysteries of 2D time? It's like being a detective, piecing together clues to unlock the secrets of the universe. But what does this all mean for us? How would our daily lives be affected by the idea of multidimensional time? Well, it could mean that we could travel to different points in time, or even different timelines. Imagine being able to see the dinosaurs. The possibilities are mind-blowing. To fully understand the idea of 2D time, we need to talk about the metric tensor. Don't worry, it's not as complicated as it sounds. The metric tensor is a mathematical object that describes the geometry of spacetime. It tells us how to measure distances and angles in a 2D spacetime. Think of it like a map that shows you how to navigate in a new city. This may look like a bunch of letters and symbols, but it's actually the formula that represents the metric tensor in 2D spacetime. It's like a secret code that tells us how to measure things in 2D time, where c is the speed of light, and ds is the distance element in spacetime. The metric tensor may seem abstract, but it's an essential tool for physicists to understand the geometry of spacetime. It's like a key that unlocks the secrets of the universe. Who knew that a simple formula could reveal so much about the nature of time and space? As we continue to explore the mysteries of the universe, the metric tensor and other mathematical tools will be essential for unlocking its secrets. Imagine being able to see how things would have turned out if you took a different job, or if you said yes instead of no to that date. The possibilities are endless. And who knows, maybe there's a parallel universe out there where you're living your wildest dreams. When we travel through time in a linear fashion, we experience time as a series of moments that exist in the past, present, or future. But in 2D time, things get more interesting. We can experience time in a nonlinear way, moving through past, present, and future simultaneously. It's like being able to jump between different moments in time as easily as changing the TV channel. It's a whole new level of time travel that we haven't even begun to explore yet. The idea of 2D time has interesting implications for the study of relativity and quantum physics. It may even provide a solution for some of the most perplexing questions in modern physics, such as how to reconcile relativity and quantum mechanics. Exploring the possibility of 2D time could fundamentally change our understanding of the cosmos and our place in it. It could reveal new insights into the nature of space-time, the Big Bang, and the origins of the universe itself. As the great physicist Albert Einstein once said, time is what we measure with a clock. But that's not all it is. It's what we experience in life, and it's what shapes our reality. With 2D time, we may just be able to understand time in a way that we never thought possible before. The possibilities are truly endless. The concept of 2D time may seem like science fiction, but as we continue to explore the mysteries of the universe, it may become an essential part of our understanding of the cosmos. Who knows what we'll discover as we continue to push the boundaries of our understanding of time and space. If you enjoyed the video, please hit the like button and consider subscribing to our channel, 2D Time, for more programs on all things time. We appreciate your support, and let us know in comments section if there's any topic related to time you'd like us to cover, or if you have any questions. Your feedback means the world to us. See you again soon. Thanks for watching.